March 17, 1943, 14:23 hours, 23,000 feet above the North Sea. The consolidated B-24D Liberator, serial number 41-23728, nicknamed Lady Luck by her crew, who had painted a four-leaf clover on her nose alongside 23 bomb symbols representing completed missions, was losing hydraulic fluid at a rate that would leave her completely dry in approximately 18 minutes. The B-24D was a beast of an aircraft, and not always in a flattering way. Four Pratt & Whitney R1830-43 twin Wasp radial engines, each producing 1,200 horsepower at 2,700 RPM, wingspan of 110 feet, length of 67 feet 2 inches, height of 17 feet 11 inches, empty weight 32,000 pounds, maximum takeoff weight 65,000 pounds when fully loaded with fuel, bombs, ammunition, and 10 men whose lives depended on every rivet holding together. She could carry 8,000 pounds of bombs to targets the B-17 Flying Fortress couldn't reach, flying at 290 miles per hour at 25,000 feet, with a range of 2,100 miles. The B-24 could fly faster, farther, and higher than almost any other American heavy bomber in 1943. It was the most produced American military aircraft of World War II, with more than 18,000 eventually built. But the B-24 had a reputation among pilots that was complicated at best and terrifying at worst. She was efficient but unforgiving. She flew fast but landed hot. Her high aspect ratio Davis wing gave her incredible range and altitude capability, but made her sensitive to stalls and difficult to control in turbulence. And her hydraulic systems, which controlled everything from landing gear to bomb bay doors to the nose wheel steering, were complex, vulnerable, and absolutely critical. Without hydraulics, a B-24 transformed from a cutting-edge bomber into 32 tons of barely controllable metal falling out of the sky, looking for a place to crash. But on that cold afternoon over the North Sea, returning from a raid on the heavily defended U-boat construction pens at Wilhelmshaven, Germany, where flak had been so thick you could walk on it, and where they'd lost 2 aircraft from their formation to direct hits, none of those impressive specifications mattered. Because without hydraulic pressure, the B-24 Liberator couldn't lower her landing gear, couldn't extend her flaps, couldn't operate her bomb bay doors if they weren't already open, couldn't activate the turret traverse systems, and, most critically, couldn't activate the main braking system that would stop 32 tons of aircraft traveling at over 100 miles per hour from careening off the end of a runway and into whatever buildings, trees, or unlucky personnel happened to be in the overrun area. The B-24's hydraulic system was a marvel of 1940s engineering and a nightmare of potential failure points. It consisted of a main pump driven by the No. 3 engine, a backup pump driven by the No. 4 engine, a reservoir tank holding 7 gallons of MIL H5606 hydraulic fluid, and miles of aluminum tubing running through the fuselage connecting actuators for landing gear, bomb bay doors, cowl flaps, and the braking system. The system operated at 1,000 pounds per square inch, enough pressure to lift a car with a piston the size of a quarter. That pressure was necessary to move heavy landing gear assemblies and massive bomb bay doors against the airflow at high speed. But it also meant that any breach in the system would result in catastrophic and rapid fluid loss. And aluminum tubing, while lightweight and easy to work with, had one critical weakness. It was soft. Softer than steel. Softer than German flak fragments. When shrapnel moving at supersonic speed met aluminum hydraulic line, the aluminum always lost. The pilot was Captain Robert "Bob" Mackenzie, 31 years old, from Portland, Oregon, where the Willamette River met the Columbia, and where he'd grown up watching float planes land on water with a grace that seemed impossible for machines made of metal and fabric. Before the war, Bob had been a crop duster, flying beat-up Stearman biplanes over wheat fields in eastern Oregon, landing on dirt strips that were barely longer than a football field, sometimes shorter if the farmer was cheap and didn't want to lose productive acreage to a runway. Crop dusting had taught Bob things the Army Air Forces didn't teach in pilot training. It taught him that aircraft could fly slower than anyone believed if you knew how to work the edge of a stall. It taught him that engines could run rougher than the manual said and still keep flying. It taught him that sometimes the only way to stop an aircraft with failed brakes was to ground loop it deliberately, rather than let it ground loop you by accident. He'd done it twice in his crop dusting days. Once when his brake line failed on a Stearman loaded with pesticide. Once when his tail wheel locked sideways on a muddy field. Both times he'd intentionally kicked rudder hard to one side and let the aircraft spin itself to a stop, rather than trying to maintain directional control and running into trees at the end of the field. Both times the aircraft had survived. So had Bob. And he'd learned something valuable. That sometimes the best way to land is to let the aircraft fall in a controlled way, rather than fighting to keep it flying when it wants to be on the ground. Bob McKenzie understood something most military pilots didn't. Something you couldn't learn from textbooks or formation flying. That flying was only half the job. Landing was where most men died. Landing was where physics stopped being your friend and became your judge, weighing your speed, your angle, your decisions, and delivering a verdict measured in crumpled metal and broken bones. The hydraulic failure had started small, as catastrophic failures usually do. A single leak in the line running to the nose wheel actuator, caused by a piece of flak no bigger than a thumbnail that had penetrated the belly of the aircraft during the bomb run over Wilhelmshaven. The fragment had been traveling at approximately 1,000 meters per second when it punched through the thin aluminum skin of the belly, lost most of its energy tearing through structural members and insulation, and finally came to rest embedded in the hydraulic line at a joint connection. The fragment had created what engineers call a stress riser, a point of weakness where cracks propagate. The initial penetration was tiny, barely visible. But hydraulic lines don't leak gracefully. They fail progressively. A pinhole becomes a crack becomes a tear, and at 1,000 psi, a tear becomes a fountain. But pinhole leaks don't stay small at pressure. Hydraulic fluid in the B-24 system operated at 1,000 psi, pounds per square inch, which is approximately 68 times atmospheric pressure. To put that in perspective, a pressure washer operates at around 2,000 psi. A hydraulic system at 1,000 psi can inject fluid through human skin and into tissue with enough force to cause gangrene and amputation. At that pressure, even a tiny hole becomes a fountain. And hydraulic fluid spraying inside an aircraft fuselage at 1,000 psi doesn't just leak, it atomizes. It creates a fine mist that coats everything, makes surfaces slippery as ice, fills the air with petroleum vapor, and, most dangerously, is highly flammable if it contacts hot metal surfaces like exhaust manifolds or turbocharger housings, or if it encounters electrical sparks from damaged wiring or arcing switches. The flight engineer, Staff Sergeant Thomas "Tommy" Walsh, had discovered the problem at 14:23 hours when he noticed the hydraulic pressure gauge dropping during his routine systems check. Normal pressure, 1,000 psi. Current pressure, 780 psi and falling. Tommy was 22 years old, from Boston, son of a plumber. He'd grown up around pipes, pressure systems, and the fundamental truth that when fluid goes somewhere it shouldn't, you have a very limited time to fix it before catastrophic failure. He crawled through the narrow tunnel connecting the flight deck to the bomb bay, a claustrophobic tube barely 22 inches in diameter that required him to move like a worm through mud, carrying a flashlight in his teeth and dragging a canvas tool bag behind him, filled with emergency repair supplies, rubber patches, hose clamps, safety wire, and the desperate hope that the leak was something he could patch with materials designed for minor emergencies, not catastrophic system failures. What he found when he emerged into the bomb bay made his stomach drop and his throat tighten with fear. The hydraulic line wasn't just leaking. It was spraying with the force of a fire hose. A fine red mist of mil H5606 hydraulic fluid, petroleum-based, mineral oil with additives, dyed red for visibility, was coating the entire forward bomb bay section. The aluminum skin of the aircraft interior glistened like it had been painted with blood. Droplets clung to every surface. The air itself seemed thick with atomized oil that caught the beam of his flashlight and turned it into a red fog. The smell was overwhelming. Petroleum-based, slightly sweet, with that chemical undertone that warned of toxicity. Tommy knew from his training that prolonged exposure to hydraulic fluid vapor could cause dizziness, nausea, and respiratory problems. He also knew that in a confined space with limited ventilation at 23,000 feet, where the air was already thin, he had maybe 10 minutes before the fumes would impair his judgment. And worse, much worse than the immediate danger, the leak was at a joint connection behind the nose wheel well, in a position that was physically impossible to reach without completely disassembling the nose wheel mechanism. The joint was recessed 6 inches behind a structural bulkhead, accessible only through a maintenance access panel that could only be opened from outside the aircraft, on the ground, with the proper tools and at least an hour of work. That would require specialized wrenches they didn't have, time they definitely didn't have, and most critically, gravity they absolutely didn't have while flying at 23,000 feet over the North Sea at 250 miles per hour. Tommy crawled back to the flight deck. "Skipper," he said over the intercom, his voice carefully controlled. "We've got a hydraulic failure. Main system. I estimate total loss in 15 to 20 minutes. Bob Mackenzie's hands tightened on the yoke. He'd flown B-24s for 11 months. He'd survived 23 combat missions. He'd brought crippled bombers home on 2 engines, with half a wing shot away, with dead crew members in the waist and fires in the bomb bay. But he'd never tried to land a B-24 without hydraulics. The B-24 Liberator was not a forgiving aircraft. It was fast, efficient, and could carry enormous loads over tremendous distances. But it landed hot, fast, at speeds that required every aerodynamic advantage the engineers had designed into it. Without flaps, the landing speed would increase from 95 miles per hour to nearly 130. Without brakes, stopping distance would extend from 3,000 feet to potentially 8,000 or more, depending on runway conditions. Most British airfields had runways between 5,000 and 6,000 feet long. The numbers didn't work. Bob keyed the radio. "Ridgewell Tower, this is Lady Luck, declaring emergency. Hydraulic failure, unable to lower gear or flaps. Request longest available runway and emergency equipment standing by." The response came back within seconds. "Lady Luck, Ridgewell Tower, copy your emergency. Runway 27, 5,800 feet, is available. Wind is 270 at 12 knots. Fire and rescue are rolling. Be advised, alternate field Woodbridge has emergency runway of 9,000 feet if needed." Woodbridge. The emergency landing field on the coast with the extra-long runway built specifically for crippled bombers. It was 40 miles further, but it offered 3,000 additional feet of concrete. Bob did the math. Current fuel state: 1 hour and 15 minutes remaining. Distance to Woodbridge, 18 minutes. But every minute they flew was another minute of hydraulic fluid spraying into the bomb bay, increasing fire risk and potentially damaging other systems. "Tommy," Bob said, "tell me straight. Can we make it another 20 minutes without the hydraulics catching fire?" Tommy looked at the hydraulic pressure gauge, 540 psi, dropping steadily. "Honestly, Skipper, I don't know. That fluid is coating everything. If it hits the hot metal around the turbo wastegates, or if there's any electrical short in the bomb bay, we could have a fire that'll burn through the fuselage in under a minute." That was the moment when Technical Sergeant James "Jimmy" Kovacs spoke up. Jimmy was the top turret gunner, 24 years old, from Pittsburgh. Before the war, he'd worked in a steel mill where the primary rule was, when something is under pressure and about to fail, release the pressure before it releases itself. "Captain," Jimmy said over the intercom, "what if we don't land with hydraulics?" "That's the problem, Jimmy. We don't have them." "No, sir. I mean, what if we don't need them?" Bob frowned. "Explain." "The B-24 has a manual backup system for the landing gear. Hand crank in the bomb bay. Takes about 300 turns to lower the gear mechanically. No hydraulics needed. And for the brakes," Jimmy paused. "What if we don't use brakes at all?" "Jimmy, we're landing a 65,000-pound aircraft. Without brakes, we'll run off the end of any runway in England." "Not if we ground loop her." There was silence on the intercom. A ground loop, intentionally forcing the aircraft into a skidding, sideways spin on landing, was something you did in a fighter when you had no other option. It was controlled chaos. It was dangerous. It put enormous stress on the landing gear. It could flip the aircraft. It could tear off the wings. But it would stop the aircraft in less than half the distance of a normal landing roll. "Jimmy," Bob said slowly, "have you ever seen anyone ground loop a B-24? "No, sir, but I've seen plenty of pilots ground loop by accident. They survive more often than they die. And right now, our alternative is either belly landing on foam, which will definitely destroy the aircraft and might kill some of us, or trying to land at Woodbridge and hoping 8,000 feet is enough without brakes." Tommy Walsh did the calculations in his head. "Captain, he's right. If we can get the gear down manually, and if we can execute a controlled ground loop, we might be able to stop her in under 2,000 feet. But the gear has to be locked. If it collapses during the loop, we cartwheel and die." Bob McKenzie had made 37,000 decisions in his life. Most of them were small. Some were important. This one would determine whether 10 men lived or died in the next 20 minutes. "Tommy, get down to the bomb bay and start cranking the gear down. Jimmy, I want you spotting for him to confirm each wheel locks. Co-pilot, you're on fuel management and systems monitoring. Navigator, plot me the straightest course to Ridgewell. Bombardier, watch for any smoke or fire in the nose section. Radio operator, inform Ridgewell we're attempting manual gear extension and will require a non-standard landing approach." The crew moved with the precision of men who'd trained together for 11 months and survived 23 missions over Europe, where the Luftwaffe and Flak guns had tried to kill them every single time. Tommy Walsh positioned himself in the bomb bay with the manual landing gear crank, a long T-shaped handle made of steel, approximately 30 inches long with crossbars for grip, that connected to the gear mechanism through a series of reduction gears at a ratio of approximately 300 to 1. That meant 300 complete rotations of the crank handle would translate into one complete extension cycle of all 3 landing gear assemblies. 300 turns to extend 3 wheels. 10 minutes of continuous cranking at 23,000 feet, where the air contained 40% less oxygen than sea level, and where every movement required twice the effort it would on the ground, where muscles burned through energy faster, and where exhaustion came not from weakness, but from simple physics. The manual gear extension system had been added to B-24s after several incidents where hydraulic failures had forced belly landings that destroyed aircraft and killed crews. It was an emergency backup, designed to be used once in a lifetime if you were unlucky enough to need it. The engineers who designed it had assumed it would be cranked by a fresh, rested crew member on the ground during maintenance testing. They hadn't accounted for it being cranked by a 22-year-old flight engineer who'd been awake for 18 hours, who'd breathed oxygen through a mask for the last 6 hours, who'd been shot at by more than 200 anti-aircraft guns during the bomb run, and who was now operating in an environment where every breath felt like trying to inflate your lungs with sand. Tommy began turning. The crank was stiff, resisting every rotation with the mechanical friction of gears that hadn't been lubricated properly, because nobody ever expected to use them. His arms burned with lactic acid buildup. His shoulders ached with the repetitive motion. Sweat dripped into his eyes, despite the -40-degree temperature outside the aircraft, despite the fact that his breath was crystallizing in the air, because the human body generates heat when it works, and that heat has nowhere to go in a pressure suit designed for insulation. But he kept cranking. 50 turns. His forearms were on fire. 100 turns. His shoulders screamed. 150. He could feel the muscles in his back beginning to cramp. "Right main gear showing movement," Jimmy called from his position, where he could see down through the bomb bay. "Keep going, Tommy." 200 turns. 250. Tommy's arms felt like they were filled with broken glass. His breathing was ragged, but the gear was moving. He could hear the mechanical grinding of metal on metal as the wheels slowly, painfully slowly, rotated out of their wells and began extending downward. At turn 287, the nose wheel locked with a solid mechanical thunk that reverberated through the airframe. At turn 293, the right main locked. At turn 302, the left main gear locked into position with a sound like a giant steel door slamming shut. "All 3 wheels down and locked," Jimmy confirmed. "Gear is solid." Bob McKenzie allowed himself one breath of relief. Then he focused on the next problem: how to intentionally ground loop a 4-engine heavy bomber without killing everyone aboard. "All crew positions, strap in tight. We're landing in 5 minutes. This is not going to be a normal approach." Ridgewell Tower cleared all other traffic. Fire trucks and ambulances lined both sides of the runway. The entire base had stopped to watch what was about to happen. Bob brought Lady Luck down from 23,000 feet to pattern altitude, configuring the aircraft as best he could without hydraulics. No flaps meant high landing speed. No hydraulic nose-wheel steering meant he'd have to use differential engine power to control direction after touchdown. He lined up on runway 27. Airspeed 135 miles per hour. Gear down and locked. No flaps. No hydraulic pressure. 10 men holding their breath. The wheels touched at 14:47 hours. The instant all 3 wheels were on the runway, Bob did something that would make every flight instructor in the Army Air Forces scream in horror. He chopped power to engines 1 and 2 on the left wing, while pushing engines 3 and 4 on the right wing to full power. The asymmetric thrust created immediate and violent yaw. The nose swung left. The aircraft began to rotate. But Bob was ready for it. He used rudder and differential thrust to control the rotation, keeping the aircraft sliding sideways down the runway rather than spinning out of control. The tires screamed. Rubber burned. The landing gear shuddered under loads it was never designed to handle. The entire airframe shook like it was coming apart. But Lady Luck stayed upright. The gear held, and after sliding sideways for 1,400 feet, leaving black rubber marks across the entire width of the runway, She came to rest, pointing 45 degrees off centerline, her right wingtip less than 10 feet from the grass. Total stopping distance, 1,430 feet. Bob shut down all 4 engines. The sudden silence was absolute. For a moment, nobody moved. Then Tommy Walsh started laughing, not from humor, but from the sheer psychological release of having survived something that should have killed them. The crew climbed out through the waste door. Their legs were shaking. Some were crying. The fire crews that had been standing by with foam and water just stared at the aircraft sitting sideways on the runway, smoke still rising from the tortured tires. The base commander, Colonel Harrison, drove out in his Jeep. He walked around Lady Luck twice, examining the landing gear, the tires, the wings. Then he walked up to Bob Mackenzie. "Captain," he said, "that was either the finest piece of flying I've ever seen, or the worst. I'm not sure which." Bob looked at his aircraft, damaged, scarred, sitting at the wrong angle on a runway, with tire marks that would be visible for years. But she was intact. Her crew was alive, and she would fly again after repairs. "Sir," Bob replied, "I think it's both." Lady Luck was repaired and returned to service 3 weeks later. The maintenance crew reinforced the landing gear, replaced the tires, and repaired the hydraulic system with better armored lines that were less vulnerable to flak damage. The ground loop landing technique Bob had used was documented and added to emergency procedures training for B-24 crews. Bob Mackenzie flew 31 more combat missions. He survived the war. He never had to ground loop an aircraft again. But he taught the technique to every new pilot in his squadron because, as he told them, one day you'll have a choice between a bad option and a worse option. You need to know how to make the bad option work. Tommy Walsh was awarded the Distinguished Flying Cross for his work manually cranking down the landing gear while the aircraft was losing hydraulic fluid. He survived the war and became a hydraulics engineer for Boeing, where he designed backup systems for commercial aircraft that would never leave pilots without options. Jimmy Kovacs, the turret gunner who suggested the ground loop, went on to fly 29 more missions. He was killed on his 30th mission when his B-24 was shot down over Berlin in August 1943. But his idea saved 10 men that day in March, and the technique he suggested would save dozens more before the war ended. The wreckage of 41-23728, Lady Luck, sits in storage at the National Museum of the United States Air Force. The landing gear still shows the stress marks from that sideways slide across Ridgewell runway. The tires were never replaced. They're preserved as evidence of what desperation and skill can accomplish when 10 men refuse to give up. And on the nose gear door, written in faded white paint, is a message that the maintenance crew added after the repair. Hydraulics optional, courage required, skill mandatory. Because that's what aviation is, a constant negotiation between what the machine can do, what the manual says you should do, and what you have to do when everything else fails. And the only option left is to try something that nobody's ever done before, and hope that physics, luck, and skill combine in exactly the right proportions to keep you alive. Now you. Did you know that manual landing gear extension was possible on World War II bombers? Have you heard of other emergency procedures that became standard practice because someone tried something desperate that actually worked? Tell me in the comments what other untold technical stories from aviation history you'd like to discover. Because behind every famous aircraft are 100 moments of improvisation that saved lives but never made it into the history books.